In this video, we will take a look at an example of how to create a probability distribution, as well as finding the mean and the standard deviation of that probability distribution. Our example problem here takes a survey of 200 Bunker Hill students and asks them how many classes they are taking this semester. The results of that survey are given in the frequency table in the upper left corner. The first part of this question asks us to find the probability distribution for the variable, the number of classes taken. So our variable in this problem takes on four distinct values, 1, 2, 3, or 4. This variable is a discrete variable. In order to create a probability distribution for a discrete variable, one of the ways I can do it is using a table. All I have to do is list out all the possible values that my variable could be and the probability associated with each one of those values. So the first half of my probability distribution would just be a column of all the values my variable could take on, which in this problem would be 1, 2, 3, or 4. The second column in my probability distribution wants the probability that x could be each one of these values, x referring to the number of classes. How I find the probability in this case is that I would use a relative frequency from the table. If 40 students took one class, well, there's 200 total students in the survey, so 40 out of 200 would give me a probability of 0.2. I do a similar calculation for the other values of x, which are the number of classes. For two classes, there are 20 students taking two classes. 20 out of 200 would be 0.1. When I complete this table, if I have a valid probability distribution, the sum of all my probabilities should add up to 1. This would ensure that I have taken into account every single possible value of x. The next thing the question asks us to do is to find the mean number of classes taken by Bunker Hill students. To find the mean of a probability distribution, the formula is given here on the left side of your slide. We use the value mu, which used to be the population mean. It still refers to a population mean, but we use it to describe the mean of a probability distribution as well, since I'm taking into account every single possible value that x could be. So that formula is the sum of x times p of x. Now to calculate this mean, I first need to find all the x times p of x values. This is a similar technique to what we used in the standard deviation formulas. So on my table I created a column of x times p of x, and I just simply multiplied the values from each of the previous two columns, my variable times its probability, to get those values. 1 times 0.2 in the first row, 2 times 0.1 in the second row, and so on. When I calculate all these values for x times p of x, that is when I want to take the sum. So adding up this third column here gives me a value of 2.75, which would be the mean of the probability distribution. Moving on to part C, I want to find the standard deviation of my variable, the number of classes taken. To find the standard deviation of this probability distribution, there's actually a few different formulas I could use. They're the same formula, but they just look different, similar to our standard deviation formulas before. The one that I use is given here on the right side because it's the easiest to calculate and requires the least amount of work to do by hand. What I want to do is take the sum of x squared values times p of x, and then I'm going to subtract the mean squared. So to compute this formula, I first want to find the values of x squared times p of x, which is what I do in the fourth column. I'm squaring my variable, 1, 2, 3, and 4, and I'm multiplying them by the probability of each row as well. When I compute those four values, I then take the sum of that column. That would be the sum of x squared times p of x. This gives me a value of 8.75 in this problem. This is the value I'm going to plug in for the left half of my formula here. So what I want to do is take that 8.75 and I want to subtract the mean squared, mu squared. Since we found mu to be 2.75, I plug that value in for mu. I square it and subtract it from 8.75. After I take the square root of that value, I should get 1.09.